Hi, I'm Reynolds Adolph, and welcome to C# Design Patterns 2. So, with the popularity of my first Design Patterns course, I decided to continue exploring more of the Gang of Four design patterns. These design patterns are basically solutions to design problems you often find in real-world applications because there's no need to reinvent the wheel if someone already found a solution that works. In this course, we're going to be covering a creational pattern like builder, and then a couple of structural patterns such as adapter pattern and composite. And lastly, some behavioral patterns, which include chain of responsibility, command, interpreter, mediator, and visitor. Alrighty, so without any further ado, let's go ahead and jump right into this. For this course, I'm assuming that you're already comfortable with object-oriented programming. Also, you should be familiar with the C# language and interfaces, solid principles, and I'll give you a reference to my test-driven development course where I cover that, and navigating through Visual Studio. If you aren't familiar with some of these or you have any questions while watching, I'd recommend checking out two of my courses, .NET Programming Introduction, C# Test-Driven Development, particularly Chapter 1, where I talk about refactoring, which is where I'll cover the solid principles. And lastly, C# Essential Training, which is a comprehensive course on the C# language by David Gassner. Design patterns can take a while to fully grasp and implement, so definitely consider revisiting this course as a reference as you continue progressing as a developer. And the last thing that I'd like to add is that I'm using Visual Studio Community 2017, and the workloads that I chose to install are .NET Desk Development on the upper right-hand corner, and on the bottom left there you see ASP.NET and Web Development, and also bottom left-hand corner, .NET Core Cross-Platform Development. However, for this course, the most relevant one will be on the upper right-hand corner, Desktop Development. All you'll need is the ability to do console apps. If you have access to the exercise files, you can follow along with the code examples that I'll be working on in this course. Within these files, you'll find a folder for each chapter of the course. And within each chapter, you'll find subfolders for each specific video. And within those folders, you'll see that there's a begin and a finish state. If you want to follow along, open up the solution ending in SLN in the begin folder. And when you're done, you're welcome to compare your code with what I have in the finish folder. One extra thing that I'd like to point out is that when you open up a solution file, sometimes the project focus might not be the one that you want. So for example, if we want to work on the adapter project here, it needs to be set as the starter project. Currently right now, it's builder, and you could tell that it is because it's bold. So to set adapter as the starter project, just right click and move on down to here, set as startup project. And now you're ready to follow along, write your code, and when you execute it, the correct project will start. If you took my first design patterns course and know conceptually what a design pattern is, then you can skip this part. But if you're new to design patterns and this is your first course on this topic, this section is for you. A design pattern is generally a reusable solution to a commonly occurring software problem. It's not a finished specification that could be transformed directly into code. Instead, you could kind of think of it as a blueprint of a solution. And what happens is, as a developer, when you think in terms of design patterns, it kind of makes it easier for you to produce a high-level solution without getting bogged down with implementation details. And when it's done right, these patterns lead to software solutions that are easily understandable, testable, and maintainable. Maintainable being one of the most important because it anticipates change to the software, and because of this, it makes it easier to update code when major changes do happen. The Gang of Four refer to four individuals that authored a book which really influenced the way we think about writing code. The authors were Eric Gama, Richard Helm, Ralph Johnson, and John Velicides. And the book they wrote was Design Patterns, Elements of Reusable Object-Oriented Software. They covered the 23 patterns which are generally considered the foundation of all other patterns. And in this course, we're not going to cover all of them, but any pattern that we don't cover can be found either in my Design Patterns Course 1 or Part 3, as laid out in this chart here. So you might ask yourself, do I really need to think about design patterns? I already write code that's easily maintainable, and my code works. Well, the thing is, you want to keep in mind that just because you don't need it now doesn't mean you won't need it in the future. Sure, if it's a program with just 20 lines of code, patterns might be an overkill. But for large programs, you want to leverage design patterns when it's appropriate because besides the fact that they provide solutions and make your code maintainable, there's two other major benefits. The first is that they provide a shared vocabulary. They make it easy to explain code rather than saying, hey, can you write code that lets you set up and alter objects at runtime by wrapping them in some class and leaving the object intact without modification? You could simply say, hey, just use the decorator pattern. The other major thing that design patterns provide is what I like to call academic motivation. Those that learn to implement design patterns and know the benefits of them might end up developing new patterns for issues that currently aren't being addressed. Someone had to initially write some design patterns, right? So who's to say that you're not going to be the next one creating a pattern that's needed for the future? And when you think of it in those terms, that's pretty cool. There are three categories of design patterns. The first is creational, then there's structural, and then behavioral. Creational patterns provide a way to make objects while hiding the creation logic, rather than instantiating objects directly. In short, they deal with object creation mechanisms. Now, structural patterns are all about class and object composition. Structural design patterns tend to ease the design by identifying a simple way to realize relationships between entities. And lastly, we have behavioral patterns, which are specifically concerned with communication between objects. That is, how objects communicate and what they communicate to each other. Highlighted in this chart are the patterns that we'll be covering in this course. And we'll be kicking it off with a creational pattern. That's up next. The first pattern I'll review is a creational pattern called Builder. Now, the Gang of Four describes the Builder pattern as being used to separate the construction of a complex object from its representation so that the same construction process can create different representations. All right, what are they really saying? All they're saying is that it's just a pattern that lets you separate and reuse a specific process to build something, like constructing an object. You'll only want to do this when the construction process is complex. Otherwise, there's really no need to do this and it'll be an overkill. If we take a look at the class diagram, we could see the players that are involved. We have a director that constructs an object using the builder interface. And to the right of it, the builder specifies an abstract interface for creating parts of a product object. Below that is the concrete builder, and that constructs and assembles parts of the product by implementing the builder interface. It also provides an interface for retrieving the product. And lastly, to the right-hand side is the product, which represents the complex object itself that's under construction. The concrete builder, to the left of it, builds the product's internal representation and defines the process by which it's assembled. This is going to make much more sense with our example. And what we're going to do is demonstrate this builder pattern in which different cars are assembled in a step-by-step fashion. We're going to have a car factory that uses car builders to construct two types of cars in a series of steps. So our diagram will look like this. The director on the upper left-hand corner is going to be our car factory. The builder is car builder. Right below it, we'll have two concrete builders, one that's called not so super car builder and a super car builder, which is to the right. Those are the concrete builders. A not so super car builder, essentially a lame car, and another one, which is an awesome car, super car builder to the right. And the product itself is the car. Let's check out the code. That's up next. All right, so we're about to walk through the code to demonstrate this builder pattern. So a few things to keep in mind. The players involved are the car factory, which is going to be the director. There's the car builder, which is the actual builder. And then there's the two concrete builders, not so super car builder and super car builder. And lastly, the product, which is the car. And that's a quick glimpse of the original diagram. So in our code, starting on line 26, you'll see that we have our car, which is the product that we mentioned in the diagram. And all we do is define the top speed of the car, the horsepower, and its most impressive feature. Those are going to be the attributes that we're going to be paying attention to distinguish the car types. Below it, our builder abstract class is named car builder. And this is where we'll instantiate a new car, set up our method stubs to set the new horsepower, top speed, and its impressive feature. And lastly, a virtual method to retrieve the car. Starting on line 52, we have our director, which is the car factory. Here is where we actually build the car. This is where the construction takes place. So the methods are invoked to set the horsepower, to set the top speed, and to set its impressive feature, and lastly, to get and return the car. Next is our first concrete builder, and that will be for the not-so-super car builder. This is where we'll specify the specific features that are unique to this lame car. It only has 120 horsepower. The top speed of it is 70 miles per hour. And its impressive features to brag about is that it has air conditioning. Now, the second concrete builder, which is for our supercar, will have a horsepower of 1640. That is pretty impressive. And then the top speed will be 600 miles per hour, and it can fly. So let's go ahead and write the client code now and see how this all pans out. So we're going to go ahead and write the code for our builder pattern. So the first thing we'll do is jump on down to our main method. And let's start off by defining some variables for super builder and not so super builder. Super builder will be a new instance of the supercar builder. And we will do the same for not super builder. Then let's go ahead and create our factory instance of car factory. Car factory. That should be a small f. It's case sensitive. Next is builders, which will have a collection of car builders. And here we will add super builder and not so super builder, not super builder. And the last thing we'll want to do is iterate through the list of builders with a for each. And we'll just say for every B for builders in builders, let's go ahead, define C for car, and we will invoke the instance of build in our factory, pass in B. So now let's go ahead and write out what we will put out in the console. And we'll use some string interpolation and start out with the car requested by, and here I will add a space and then just hit enter. And if you're working with this version of Visual Studio, it should automatically add the plus sign for you so you can continue writing, which is actually a pretty cool feature. So here I will add in curly braces the type name that we're working with, get type, and write out the name, colon, and I will continue to the next line. And now I want to just add a new line just to keep things neat and separate it with these dashes. And here I'll add a new line and write out horsepower. And that will be C dot horsepower, the car's horsepower. I'll hit enter before the ending quote so that it can continue. And I'll do new line, impressive feature, colon, space. And we'll write down the car's most impressive feature. And the last thing will be the top speed of the car. Car dot top speed. And we'll add a space and write miles per hour and just add a new line. All right, looks good. So now I will go ahead and execute the program by holding the control key down and hitting F5. And all this does is run the program, but also pauses the screen so that in our code, we didn't have to write console.read key. And there we go. We have our first car that's requested by Supercar Builder. It has a horsepower of 1640. Its impressive feature is that it can fly. Also, it goes 600 miles per hour. That's its top speed. That is pretty cool and impressive. And so for the car requested by the Not So Supercar Builder, we get a car that only has horsepowers of 120. Its impressive feature, it has wonderful air conditioning, and it goes up to 70 miles per hour. The builder pattern is pretty similar to the abstract factory, but the abstract factory works more with a family of objects, whether or not they are simple or complex. However, the builder pattern focuses on constructing one product that's a complex object step by step. So if you come to a situation where you need to construct an object that's fairly simple, this might be an overkill. However, if it is complex, then this would be the pattern for you to use.